This might be the slowest hunt in nature. There's no chase, no teeth, no violence in the way we usually imagine it. Yet what's happening here is one of the most unsettling forms of predation on Earth. What you're watching looks harmless at first. A baby starfish inching its way across the seafloor toward a snail or a clam. No urgency. No aggression, just slow, deliberate movement. We don't usually think of starfish as predators at all. They're colorful, symmetrical, and often treated like decorations of the ocean. But if you stay with the scene long enough, something uncomfortable begins to settle in. This isn't a coincidence. This isn't curiosity. This is a hunt. Starfish, more accurately called sea stars, belong to a group of animals known as Their close relatives include sea urchins, sand dollars, and brittle stars. None of them look anything like mammals, fish, or reptiles. And yet, they are animals with mouths, digestive systems, and highly specialized ways of feeding. The difference is that almost everything about them works in reverse of what our instincts expect. A starfish doesn't bite. It doesn't chew. It doesn't swallow prey. In fact, it doesn't even keep its stomach inside its body while eating. Instead, it uses one of the strangest feeding mechanisms in the animal kingdom. When a starfish decides to eat, it pushes its stomach out through its mouth, wraps it around its prey, digests the animal externally, and then pulls the liquefied remains back inside itself. That fact alone sounds disturbing, but it raises an obvious question. How does a creature that moves so slowly and has no teeth manage to eat animals protected by hard shells? Clams, mussels, oysters, and snails are not defenseless. Their shells are made of calcium carbonate, a material strong enough that humans study it for engineering and structural design. The two halves of a clam shell are sealed shut by powerful adductor muscles that can clamp with immense force. Once closed, there is no obvious gap, no opening for claws, jaws, or tools. Crabs rely on brute force to crack shells. Fish may try to smash them against rocks. Many predators fail outright, but starfish succeed, and shellfish make up a large portion of their natural diet. The method is not fast. It is not dramatic. It is relentless. If you look beneath a starfish's arms, you'll see hundreds of tiny tube feet arranged in rows. Each foot ends in a soft, suction-like pad. They don't look dangerous, but these feet are powered by a hydraulic system, not muscles. Starfish use a water vascular system, pumping seawater through internal canals to control movement and grip. This allows each tube foot to generate steady pulling force without fatigue. When a starfish finds a clam, it slowly positions itself on top of it, draping its arms over the shell. Tube feet attach one by one. There is no jerking motion, no sudden force, just constant pressure. The clam responds the only way it knows how, by clamping shut and holding on. That defense works well against predators that rely on short bursts of strength, but it fails against patience. The clam's muscles must actively contract to stay closed, burning energy the entire time. The starfish, using hydraulics, does not tire. Minutes pass, hours pass, sometimes an entire day. Gradually, the clam's energy reserves run out. The shell doesn't open wide. It doesn't need to. It separates by a fraction of a millimeter. That tiny gap is enough. At that moment, the starfish deploys its most unsettling adaptation. The cardiac stomach begins to emerge from the starfish's mouth. It stretches, soft and flexible, sliding into the gap between the shells. Once inside, digestive enzymes are released. The clam is not swallowed, it is dissolved. Alive. This digestion happens outside the starfish's body. The prey's tissues are broken down into a nutrient-rich liquid, which the starfish then absorbs by pulling its stomach back inside. A second stomach completes digestion and distributes nutrients through long digestive glands that extend into each arm. The entire body feeds from this single event. If you ever see a starfish hunched motionless over a shell, this is what's happening. There is no struggle visible, no sign of violence, just time. This method works not because starfish are intelligent in the way mammals are, but because they are exquisitely specialized. They don't have a centralized brain. Instead, they have a distributed nerve net. Each arm can sense, react, and coordinate with the others through simple electrical and chemical signals. There is no conscious decision, just execution of a biological program refined over hundreds of millions of years. Starfish do have eyes, though not the kind we recognize. At the tip of each arm is a small, light-sensitive eye spot. It cannot form images, but it can detect, contrast, and shadow. This helps the starfish orient itself in its environment, guiding it toward darker areas like reefs or seabeds where prey is likely to be found. More importantly, their tube feet are packed with sensory cells that can detect touch, temperature, and chemical traces in the water. Shellfish buried beneath sand still release faint chemical signals to a starfish. These signals act like a trail. Even baby starfish can follow them with surprising accuracy. What makes this more unsettling is that starfish are born knowing how to do this. They don't practice. They don't learn through trial and error. Juveniles perform the same feeding behavior as adults, extending their stomachs into tiny shells and digesting prey externally. This behavior is entirely innate. From an evolutionary perspective, this makes sense. Starfish have existed for over 450 million years. They survived mass extinctions that wiped out countless other species. Their slow, methodical feeding strategy works in environments where speed and aggression are not advantages. In tide pools and reef systems, patience beats power. A starfish does not need to chase. It does not need to overpower. It only needs to wait. Scientists have become increasingly interested in starfish biology for this reason. Their hydraulic movement system has inspired research in soft robotics. Engineers are studying tube feet to design robotic greepers capable of handling fragile objects or navigating complex underwater environments. The same principles may one day be applied to medical devices that move safely inside the human body. It is strange to think that one of the most alien-feeling predators in the ocean could help shape future technology. But that's often how evolution works. The solutions that seem most unsettling to us are often the most efficient. In an ocean filled with fast swimmers, sharp teeth, and sudden violence, starfish operate on a different timeline. They don't chase their prey. They wait it out. And in that slow, silent contest, they almost always win. Thanks for watching. If you found this fascinating, don't forget to like and subscribe for more deep dives into the weird and wonderful corners of the natural world.